Hi there. Let me take you through another way to organize the information regarding IU and Purdue fans. We had organized this information already in a table on the front of your handout. I want to show you how to organize it in something called a Venn diagram. So the two events, being an IU fan and being a Purdue fan, they are represented by these circles. And we allow these circles to intersect because it is indeed possible to be both an IU fan and a Purdue fan. That's what this number represents right here. There are 4 fans of both IU and Purdue. So as I use these numbers, I'm going to check them off. So this 4 would go inside of this section here, right in the middle, the intersection of both the IU and the Purdue fan circles. So now notice, we know that there are a total of 15 IU fans. So all IU fans are represented by the IU circle. So notice if I highlight the IU circle, I've already got 4 fans inside of that circle. So the total of this circle has to be 15. I'll even write that in. A total of 15. Well, I've already got 11. So what that means, this space contains 11 fans. So this crescent-shaped space out here, I said this space here contains 4 fans. That means this crescent-shaped space right here has to contain 11 fans because the total has to be 15. So I know that there are 7 fans then of neither school. So those fans can be in neither the IU circle nor within the Purdue circle. So in that case, we're talking about this space outside of both of the circles. So this is where we will put those 7 fans that are fans of neither school. I'll put them right here. There's the 7. So the last piece of information that I have then is there are a total of 26 fans. So down here I'm going to put that the total in this diagram has to equal 26. Well, I've already accounted for this space in the middle, the intersection. I've accounted for this crescent here. I've accounted for the space outside of the circles. So the only thing left is this crescent here. So I know the 11 plus the 4 makes 15. 15 plus 7 equals 22. So I know to get to my total of 26, I have 4 left. Those 4 have to be in this crescent right here. And now I have used all the numbers and I have organized all of my information. This Venn diagram contains the same information as what we had in the table on the front. If you like this better, you should feel free to use this strategy. So let's take a look at the probability questions that I wanted you to consider. So number 7. In order to be a Purdue fan, you have to be inside of the Purdue circle. So I can just count all of the observations inside of the Purdue circle. That includes the 4 and the 4. That makes 8. So those 8 are what I want. That would go in the numerator. And the total, what's possible is I could have selected anyone within the rectangle, and I know that that total is 26. So 8 out of 26 would be my probability. Notice you can get exactly the same probability from having used the table on the front. I have it right here. So again, the total number of Purdue fans, there were 8 total out of a table total of 26. There's the 8 out of 26 once again. So you could use either the table or you could use the Venn diagram strategy. Either one of these will work in order to organize your information for your probabilities. So for number 8, I am interested in the likelihood of choosing a Purdue fan given that I'm only looking at the IU fans. So this condition right here tells me the circle that I am limited to. So this condition tells me I am to look only within the IU circle. So I'm only going to look inside of the IU circle right there. And from within that IU circle, I only want to pick the Purdue fans. So within the IU circle, there are 4 fans that are also Purdue fans. So I'm interested in those 4. That's what I want. But again, what's possible, because I'm only looking at the IU circle, there are only 15 possible subjects that I could select. So this conditional probability is 4 out of 15. And again, we could have gotten the same thing by looking at the table. So conditionally then, if I'm only looking at IU fans, the number of Purdue fans, there are 4 Purdue fans out of a total of 15 from that column in the table. So Purdue complement. understand this little c right here stands for complement. So another way to think about that is I want the probability of selecting someone who is not a Purdue fan. So there are a couple of ways to do this. Someone in the day today suggested that C, think of that as cover. So in my Venn diagram, I could cover up the Purdue circle because I don't want someone from the Purdue circle. So if I cover up the Purdue circle, the values that are left in the table then are the 11 and the 7. So what I want is someone not in the Purdue circle. I've covered it up. That gives me 11 plus 7, or 18 observations out of the total of the 26 that I would be interested in. So there we go. There's my probability. Another way to think about a complement, understand, I'll write it over, well, I guess I can just write it up here. So the probability of Purdue complement, of not a Purdue fan, is 1 minus the probability of having a Purdue fan. Well, up here I've already calculated the probability of having a Purdue fan, so I could take 1 minus 8 out of 26. You can make a common denominator. The 1 is 26 out of 26. Take away 8 out of 26, and once again that will give you the same 18 out of 26. So the other thing you could have done is gone and looked at the table. I'm interested in people that are not Purdue fans. So within the table where that information is located, the total of not Purdue fans is 18, the total of that row out of a total of 26 in the table. So what I want you to see is there's more than one way to solve these questions, to find these probabilities. It's just a matter of, do you prefer to organize them in a diagram or in a table? So here's another conditional probability. Again, the condition is I'm interested in looking only within the IU circle, and I want individuals that are not Purdue fans. So in my diagram, here I am in the IU circle, so that's the condition. I am restricted to being within the IU circle, and I want the people that are not Purdue fans, so I'm going to cover up anyone that's a Purdue fan, and what I'm left with are those 11 out of the IU circle, which totaled 15. That would be 11 out of 15. Again, to check ourselves, we can look at the table. In the IU column, we can count up the fans that are not Purdue fans. So here is the IU column. There are 11 that are not Purdue fans out of a column total of 15. There's the 11 out of 15 again. Then the last probability, I'm interested in starting with a group of individuals that are not IU fans. So that's my condition. So not IU fans, that means I'm going to cover up the IU circle. So I'm only interested in working with this 4 and 7. So what I want then is represented by this part of the probability. I'm interested in finding Purdue fans. So there are only 4 that remain in the Purdue circle out of a total of 11. Because again, I am not looking at the IU fans. So that's a total of 4 out of 11. And then finally, we can check ourselves again by going and looking at the table. I am interested in not IU fans. So if I am not interested in IU fans, I am interested in this column here. And from that column then, I want to find the fans that are Purdue fans. That would be these 4 out of a column total of 11. Once again, there's the 4 out of the 11. So the reason I wanted to show you this Venn diagram, yes, there are a couple of book problems that use this idea of a Venn diagram in order to organize the information. So I think it can be helpful. I think some people tend to like this picture. They like the notion of the circles, covering up the circles, organizing the counts in this way. The truth is, though, if there is absolutely nothing wrong with the table strategy, if you're comfortable with that, you can continue using that. Hope this has been helpful.